Welcome to Kettle Lab's How-To series. Today we'll demonstrate how to use Fabric machine learning for model tracking and management. Sign into Fabric and let's get started. We begin by loading the data into a PySpark data frame. Once the dataset is loaded, it is stored in a variable for further processing. Next, the PySpark data frame is converted into a Pandas data frame. A new column, risk, is then created using a specified formula. Alternatively, Fabric's data wrangle feature can be utilized to simplify feature engineering through an intuitive interface, enabling the effortless application of complex transformations. To gain insights into the data, we calculate descriptive statistics using the describe function. This provides a quick summary of key metrics such as mean, standard deviation, and more. We proceed by importing the necessary libraries from sklearn for model creation and evaluation. Using the train-test-split method, the data is split into training and testing sets. To monitor model performance, we employ MLflow for logging metrics and parameters. Initially, we create an experiment for a linear regression model to effectively track its performance. Similarly, we set up another experiment for a logistic regression model. For the linear regression experiment, we navigate to the run list section to review the model's performance and evaluate its behavior across various parameters. The same steps are repeated for the logistic regression model. To further refine our models, we modify the test size for the logistic regression experiment and create a new version. This enables us to compare the new version with the previous one and select the model that delivers superior performance. The same process is repeated for the linear regression model, ensuring all relevant cells are rerun. For the logistic regression experiment, we navigate to the Run Detail section to examine the newly created experiment. To enhance clarity, we rename the models with version labels and compare their performance metrics. Additionally, we modify the test size iteratively and repeat the process for both linear and logistic regression models. By experimenting with different test sizes, we aim to identify the best performing model version based on its performance statistics in MLflow's Model Stats view. For each iteration, model metrics are logged in MLflow to facilitate configuration comparison and identify the optimal version. This iterative approach ensures the models are fine-tuned for maximum performance before deployment. Stay tuned for more tutorials on Fabric. Thanks for watching!